Section 4.2 introduces us to polynomial functions. We begin with some definitions. A term is either a constant or variable or the product of a constant and one or more variables raised to powers. Terms are added and subtracted. A monomial is a simplified term in which all variables are raised to non-negative integer powers and no variables appear in a denominator. A coefficient of a monomial is the constant or number factor. Sometimes it's called the numerical coefficient. The degree of a monomial is the sum of the exponents on the variables. And if there's just one variable, it's the power on the variable. A polynomial is a monomial or a finite sum of monomials. The degree of a polynomial is the largest degree of its terms. The leading coefficient of a polynomial in one variable is the coefficient of the first term. That's the term with the highest degree when we write a polynomial in standard form. A polynomial function is a function defined by a polynomial. Let's look at some problems that will help us to clarify these ideas. Our first monomial is 7. The coefficient of that monomial is 7. The degree of the monomial is 0. Because I can write 7 or any other number that's my monomial as 7 times any variable to the 0 power or any product of variables to the 0 power. And notice if I add the powers on the variables, no matter how many variables are there raised to the 0 power, the result will be 0. So that's the degree of a constant. It's always 0. 8x squared is my next monomial. The coefficient of that is 8. The degree of 8x squared is 2. That's the power on the variable when my monomial just has one variable. 6x squared y cubed has a coefficient of 6, and the degree of that monomial is the sum of the exponents on the variable, 2 plus 3, which is 5. Now in our next set of problems, let's write each polynomial in standard form. Then let's find its degree and leading coefficient. So I look at the degree of each term. Since each term has only one variable, the degree will be the power on the variable. And I write the largest term first and write these terms in descending exponent order. So in standard form, this polynomial is negative x to the 6 plus 5x cubed minus 3x squared plus 7x minus 2. The degree is the degree of the term with the highest degree, and that is negative x to the 6. The degree, remember, when there's only one variable in a term, is the power on that variable. So in this case, that power is 6. So the degree of that is 6. The leading coefficient is negative 1. And notice that 1 is unwritten. Also notice there's an unwritten power of 1 on the x in 7x. And I could think of there as being an unwritten x to the 0 being multiplied by my constant, negative 2. The next polynomial in standard form is negative y to the 4th plus 6y minus 121. 4 is the degree. And the leading coefficient is negative 1, the coefficient of the term that's written first when my polynomial is in standard form. Now we're going to use function notation. So our function here is called f of x. When I find f of negative 2, I replace all the x's in the function with a negative 2. So I square negative 2. Then I subtract from that 2 times negative 2, and then I add 5. Following the order of operations, I get 4 plus 4 plus 5, which equals 13. Now I want to evaluate Q when M is replaced with -3. So I replace all of the M's with -3 and use the order of operations. So following the order of operations, I wind up eventually with 81 plus 12 plus 7, which equals 100. Now, essentially, I could also say Q of -3 equals 100. In the previous problem, I could have said F of -2 equals 13. So those are my final answers in each case. I can add polynomials. And when I add polynomials, I add like terms. 3 minus 4 will be multiplied by x cubed. Those are the coefficients of my x cubed terms. I have a single x squared terms plus x squared. Then -5 plus 2 is going to be the coefficient of x. -13 minus 5 is going to be my constant. So I wind up with -x cubed plus x squared minus 3x minus 18. And this is how I would add these two polynomials. I can also subtract polynomials. And I just have to make sure that I subtract every term of the polynomial being subtracted. So 2 minus -4 is multiplied by p squared. 3 minus -6 is multiplied by p. 14 minus 8 is my constant. And these subtractions, when convenient and helpful, can be changed to additions to give the final result of 6p squared plus 9p plus 6. And in the final problem, number 10, I'm actually using function notation. So when I'm asked to find r minus p plus q of x, that's the same as finding r of x minus p of x plus q of x. And the definition for those functions is given above. So I replace r of x with 5x to the fourth minus 4x cubed minus 3x minus 7. And I subtract from that every term of p of x. So I subtract from that x cubed minus 2 of x, and then I add to that every term of q of x. -2x cubed minus 4x squared minus 3. And I can change the subtraction to an addition as long as I change the sign of every term that was being subtracted. So when I combine my like terms, I'm going to get 5x to the fourth plus a minus 4 minus 1 minus 2 times x cubed minus 4x squared plus -3 plus 2 times x plus -7 minus 3. So this winds up being 5x to the fourth minus 7x cubed minus 4x squared minus x minus 10. So that's my function r minus p plus q of x. Now when I go to the next part of this problem, I'm being asked to find r minus p plus q of -2. Now that is the same as finding r of -2 minus p of -2 plus q of -2. So if I go into r and replace all the x's with -2 and subtract from that p where all the x's have been replaced with -2 and add to that q where all the x's have been replaced with -2, then I'll find what I'm being asked to find. But since that would be the long way to solve the problem, since I already found r minus p plus q of x, I can use my result from the previous part of this problem and replace every x in that result with -2. Since I've already done the work in part A, this is the quickest way to solve this problem. And then I use the order of operations. First, I evaluate my exponents. -2 raised to the 4th power is 16. -2 cubed is -8. The square of -2 is +4. When I subtract a -2, that's the same as adding 2. Now I multiply. 5 times 16 is 80. -7 times -8 is +56. -4 times 4 is -16 plus 2 minus 10. And I can actually work with this in any order as long as I respect the signs that are in front of each term. So 56 minus 16 is 40. 2 minus 10 is a -8. So the result is 120 minus 8, which is 112.